Assalamualaikum and good day all. See you again here in the topic in chapter 6. As I promised before, I will explain more detail in electric field. So I will go to how to calculate, how to describe electric field in this topic. So actually, electric field is come from 2 point or pole, we call dipole within the two charge, electrical charge within two electron and proton. So we will create the electric field. So the formula, if we consider the Q1 more than 1 or between of the electrical charge, it should be by dou E equal to 1 per 4 pi per infinity times 2 dou Q. Dou Q is mean Q is within 2Q. So in the small of Q and divide by distance square. So we can simplify by rewrite force E, electrical field, equal to integrate within the limit, lower limit, and the upper limit. So dou E. Okay. Remember that the electric field is a vector. So you will need to separate integral for each component. So if you want to calculate for E1, for example, should be separately by E2. Okay. So in the previous example, if we are very close to the this, if Z less than R, the electric field should be E equal to tau divided by 2 permittivity. Okay. Okay, this one is to charge between the electron and the proton. So this will create the electric field. Yes. So electric field meet within the negative end with the positive end. Okay, the number of field lines starting, ending, and positive negative charge is proportional to the magnitude of the charge. The electric field is stronger where the field lines are closer together. Okay. Okay, this one is an example of line of electric field within the positive charge and the negative charge. So this one, the line is we call electric field line. So the electric field within them, within the charge positive and negative. Okay, this one, example of two condition within positive and negative charge. So the electric field within the field, the end of the electric charge. So end of the positive and of negative. So the power or the quantity of the key proportional to distance, remember. Okay, from the summary, we can take a conclusion. And the conclusion is like the point from the electric field. Field line. Field line indicate the direction of the field. The field is tangent to the line. Okay. The magnitude of the field is proportional to the density of lines. Field lines start on positive charges and on negative charges. The number is proportional to the magnitude of the charge. Okay. This one is within the conductor. So the electric field within the conductor object or material. So if we consider the inside diameter is positive and the outside outer of diameter is positive. So the electric field within the positive and negative So the line will distribute around this line, positive and negative line. Okay, electric field conductor have the direction and what we call this one is the resultant of E. If E in this direction and in direction in certain of quantity, and then we will influence another resultant, another force, a vector of the E, we call resultant of electric field. Okay, the force on object of Q, an electric field E is given by formula F equal to Q times E. This one if Q negative, okay? If Q positive is will similar direction with the F, yeah? Yeah. Okay, actually the condition of electric field is influenced by dipoles electric charge. Dipole is mean two poles, yeah? Two within the Q negative and Q positive. So L is considered as distance. Okay, this one is the electric poles by dipoles condition, 2 point, this formula. Okay, if we have 2 point dipole, Q negative and positive within, we'll have a one what we call this one influenced by E field in certain quantity in certain direction, and then we have E in the resultant. So we got formula like this. Okay, I think for theoretical in the electric charge and electric field, we can take some of point here. Or the first two kind of electric charge is positive and negative, and then charge is conserved, and then charge on electron is a fixed or constant number. Electron number is equal 1.602 times 2, 10 power negative 19 in the unit of Coulomb. And then another point, we can take a conclusion, conductor is electron free to move. Yeah. So electron can freely move in the material we call the conductor. While for insulator is non-conductor or opposite of conductor. So cannot freely transfer or charge in the material. Okay. Another point in the conclusion, we can say a charge is quantized in the unit of E, electron charge. Yeah? So when we calculate, we can get the final charge is in the E. E is a Coulomb unit. Object can be charged by conduction or induction. Coulomb law, F equal to, this one is a force that occur within two electric charge. So the F. And then by derive the K constant that relate to the permittivity, we can simplify the equation force by 1 over 2 4 pi epsilon is a permittivity, and then times 2 q1 times to q2 over 2 distance square, and then permittivity itself relate to the uh, constant k by this one. And then how to relate it to the electric field, the formula F, force, by E equal to F over to Q. Okay, now we go to next summary. Electric field we can derive from simple formula of F, and then we derive the of F, and then simplify of electric field equation by E equal to K times to Q over to distance square R. So electric field can be represented by electric field lines. Static electric field inside conductor is 0. Surface field is perpendicular to surface. Okay, if we consider a 0, because perpendicular to surface. Okay, now we go to example how to implement or apply that formula to find the electric force and also electric field. Okay, for number 1, this one is one example how to use electric charge force within two charge within positive and negative, correct? Okay, we go directly to the question. To point charges QA equal to, in the positive, positive X microcoulomb, and then QB is equal in negative microcoulomb, aspirated by a distance R equal to 10 centimeter. So what is the magnitude of the electric force? So the equation is electric force. The constant K, while constant K equal to 8.98 times to 10 power 6 meter square coulomb. So fine. So before we answer, so we make what parameter as known and what parameter as unknown. So we go first, unknown first. So unknown first. Sorry, known first A. A charge is positive 8. Yeah, and then second one, charge B is negative 5, right? And then constant K. And then the distance is 10 centimeter because we use MKS unit, meter, kilogram, and then second, MKS. So we convert first centimeter into the meter unit. So wanted mean the unknown, the question, the magnitude of the electric force. So F, based on the formula, F equal to K QAQB over to RAB square. So just input all parameter inside the formula. So we can find the F with the unit N. So because F is force, should be in MKS unit is Newton. And then we go to second example. 3 charger particles are arranged in the lines as shown in figure below. Charge A is negative microcoulomb, charge B positive microcoulomb, and charge C negative 12 microcoulomb. So we have 3 of charges A, B, and C with the certain and direction. Calculate the net electrostatic force on particle B due to the other two charges. So we have distance between A and B is 6 centimeter, while B and C is 4 centimeter. Now we go to how to solve. As usual, I said, so B give a known parameter first. After we know what the parameter known, now we go to what the question. Okay. So the question is magnitude and direction of net electricity force on particle B. Okay. We use first calculate one by one within the distance A to B with the FAB. So we input all parameter inside the formula for distance AB first. And then after we get the F for AB, then we calculate for B to C, okay? FBC. This one is should be C, yeah? Okay. After that, after we get the single number, not single number, it's made the single of action, acting of force for A, B condition. And then A, B means the BC. This one is BC, sorry, BC. And then we calculate for resultant A and B. So because of B to C is negative, B to C is negative, where you sum to calculate resultant, put as negative in the formula and the calculation also. So this one is for resultant. Yeah. So the resultant in the positive. So positive mean if you consider the positive is to the right, it mean the force is to the right. Okay. So now we go to next example. Yeah, this one is an example for electric field. Yeah. So to charge QA is 1 microcoulomb and QB is 4 microcoulomb. Separated by a distance 4 centimeter and K constant 9 times to 10 power 9 Newton. And what is the magnitude? The question is what is the magnitude of electric field and the center between QA and QB. Okay, we go to the answering. Known parameter, we have charge A is positive, charge B also positive, and K, and distance, distance between the AB, and then radius, radius A is mean the center of atom. Atom A is 0.02 meter, and radius atom B is 0.02 meters. Then the question is magnitude of the electric field. Okay, we go to calculate first at point A. So electric field at point A, just directly input all parameter into the formula. So we got for electric field EA. And then for electric B, same method, just input, and then we can get the electric field for point B. And then for resultant, because it's opposite direction, so the 2.25 is considered negative, And then we got the electric field is positive. Yes. Okay. I think that's all for our class in the chapter 6. Yeah. So don't forget for your attendance, please submit your summary into the ULearn. And then I will consider you attend the class. Okay, see you in next chapter, also in electrical, chapter 7. Assalamualaikum and good day.